Today we're going to talk about the zero product property. Now I realize that this is different than what we have been doing in class. However, with tomorrow being Halloween and we're having shortened periods, I wanted to squeeze this in for Friday. So letter A says solve the equation for x. This is nothing new. To solve for x, you would know you would just have to add 6 to both sides. And you would end up getting x equals 6. Letter B. Solving that for x. Well, my first step there would be to subtract the 4. That would leave me with x divided by 2 equals negative 4. To get rid of the 2, I would multiply by 2 on both sides. That would allow me to get rid of that fraction. The 2's cancel, so I'm left with x equals negative 8. So really, nothing new on A and B. Letter C, give 2 solutions to this equation. Now I want you to look at this versus A and B. Notice when x minus 6 equals 0, you got a value is equal to 6. And when x over 2 plus 4 equals 0, we got x equals negative 8. So when I have x minus 6 times x over 2 plus 4 equal to 0, what I am able to do is, when it's combined by multiplication, I can separate the factors. Each of these are called factors. And I could solve them separately. And I've already solved them. So I've separated the factors. I'm going to set them both equal to 0 and solve. I get x equals 6. I'm not going to show my work all over again for the one on the right hand side, but I get x equals negative 8. The reason I am allowed to separate my factors and solve is because of this reason right here. I have it written below, and then I'm going to explain it. The zero product property states that if A times B equals 0, then either A has to be 0 or B has to be 0, or maybe they are both equal to 0. I want you to think about that for a minute. The only way that a product, A times B, would equal 0 is if one of the factors had to be 0, meaning A is 0 or B is 0. And they both can be if I want them to, and that's exactly what that's saying. So if A is 5, 5 times what would equal 0? Hopefully you're telling me B would have to be. Or maybe I said B is 5. So I had A times 5 equals 0. And I would say, well, what does A have to be? In order for that to be true, A would have to be 0. So that shows no matter what A or B is, in order for the product to equal 0, one of them has to be a 0. So the way we can figure it out is we set both factors equal to 0, and that gives us values for x that would make the equation true. Okay, so let's practice using that zero product property. Exercise 2 says consider the equation x minus 4 times x plus 3 equals 0. Rewrite as a compound statement. It says, will you use the and or the or in your sentence? Well, if you remember what I said, in order for the equation to be true, one of the factors has to be 0, meaning either x minus 4 is equal to 0 or x plus 3 equals 0. So that's how I'm going to write as a compound statement. And notice I use the word or. So x minus 4 would have to equal 0 or x plus 3 is equal to 0. And remember, with an or statement, only one has to be true. Letter B says find the 2 solutions to the equation and write it in set notation. So to find the solution, you solve by adding 4. So x equals 4. Or in this case, you subtract 3. X equals negative 3. To practice our set notation, we say x is a member of the reals such that x equals 4, hold on one sec, or x equals negative 3. Okay, so that would be your set notation there. If necessary, please pause the video to write that down. Let's look at our next example. Our next example says which equation below would have a solution set of negative 5, negative 4. Now some of you can probably see the answer right away. But one way to figure it out would be to solve choices 1 through 4 and see which one gives me values of -5 and -4. The way we solve it is by by setting each factor equal to 0. So I'm looking at choice 1 right now. When I set x minus 5 equal to 0, I'd have to add 5 to both sides to solve, and I got x equals 5. And I add 4 to both sides in this case, and I get x equals 4. So the equation, number 1 would have the solutions of 5 and 4, not -5 and -4. So it can't be choice 1. And I would continue that process, but I want you to look at something. Notice how in my original for number 1, my signs were negative and my answers were positive. And in this case, my answers are negative, meaning my original equation had to be positives on both of them. And if you didn't see that, that's okay. We're going to work with this more in the future. Or you could have tried all 4 options. I was just trying to save us some time to see the trick. So our answer to exercise 2C is choice 4. All right, moving on to the next page now. Okay, on this page we are going to continue practicing. Letter A says, let's solve the following equations for x together. Hint, factor first. And factoring has been a little while, and factoring isn't our easiest topic. However, we're going to just remember with factoring, the very first thing we do is we look for a GCF, or the greatest common factor. Something that's common between the 2x squared and the 10x. The factor that is common is a 2x. They both have a 2 common and they both have 1x common. When I take a 2x out of a 2x squared, I have an extra x left over. And when I take a 2x out of 10x, I have an extra 5 left over. Equals 0. Now, it might not look like the ones in the front, but I do have 2 factors here. So I can separate my factors, set them equal to 0, and solve. So I get x equals 0. And on the right-hand side, I get x equals 5. And we're going to practice again for letter B. Now, letter B is written differently than you're used to seeing, but I still would have to find a GCF, or a greatest common factor. Now, the greatest common factor between the first term and the second term is an x minus 3. They both have x minus 3 in common. So I'm going to say that that is my GCF. And then afterwards in parentheses, just like I did over here, I have to write what I have left. I'm going to write what I have left in this set of parentheses right here. In the first factor, I have an x left over. And in the second factor, I have a plus 5. Again, notice this is my whole first factor, and I took out an x minus 3. So I'm left with x. And in the second factor, I took out the x minus 3, so I was left with plus 5. Now that I have factored it, I can set both factors equal to 0 and solve. That's usually the easy part. So I get x equals 3, and I subtract 5 on the right-hand side, and I get x equals -5. Pause if necessary, but I am going to move on. See the ones below that say try these 1 through 6? You are going to try those after I am done with the video. So you're going to go back and try those 6 problems after I am done with the video, please. Let's continue with exercise 4, though. Exercise 4 says solve for x. Well, this seems to be going backwards a little bit. I feel like we did this already. But take a look at what I do. On letter A, you would just subtract 2. Get x equals 3. Nice and easy. Letter B, you can't do that yet. Okay, what you have to do is you have to get your x values together first. So I'm going to start by subtracting the 5x. I'm going to set it equal to 0. So I get x squared minus 3x equals 0. From there, I'm going to factor out a GCF. I'm looking for a common term between x squared and minus 3x. My common term is an x. When I take an x out of x squared, I'm left with an x. And when I take an x out of -3x, I'm left with a -3. From there, I have my two factors. I can separate them, set them equal to 0, and solve. On the left-hand side, you get x equals 0, and that's it. On the right-hand side, you get x equals 3. Okay, moving on to letter C. For letter C, I do notice I have that common factor, and I hope you see it too. Before I can take out that common factor, I'm going to set it equal to 0, just like I did with letter B. So I'm going to subtract the whole factor, 5 times 5x minus 20, to the other side. That'll leave me with x times 5x minus 20 plus 2 times 5x minus 20 minus 5, and I'm going to move over, times 5x minus 20 equals 0. From there, we take out a GCF, and in all three terms, I see the 5x minus 20. So that's going to be what I take out. When I take a 5x minus 20 out of the first term, I'm left with the x. In the second term, I'm left with a 2. And in the third term, I'm left with a negative 5. So that's what I'm going to write in the other set of parentheses. X plus 2 minus 5 equals 0. From there, I separate both factors and solve. I'm running a little low on room, so I'm going to add 20 without showing it. And I'm going to divide by 5 to get x equals 4. On the right-hand side, I'm going to combine like terms, so x minus 3 equals 0. And then I'm going to add 3 to get x equals 3. So my answers are x equals 4 and x equals 3 for letter C. Pause if necessary, but again, I'm going to move on. Okay, exercise 5. Show that both sides are equal. To show that both sides are equal, what you're going to do, and it looks like my signs are missing, is what I'm going to do on the left-hand side is I'm going to factor that. Or I'm sorry, I'm going to either FOIL it or double distribute or use the box method. I'll use the box method. So I have a minus 5 and a plus 5. A times a is a squared. A times negative 5 is negative 5a. A times 5 is 5a. And 5 times negative 5 is negative 25. From there, I can write it out. I have like terms right here. Negative 5a plus 5a minus 25. The 5a's cancel, so I'm left with a squared minus 25 equals a squared minus 25. So we showed that they were equal. We're going to do the same thing for letter B. Another box method for x plus 2, x minus 2. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. From there, I can rewrite it. I do notice I do have like terms in the middle. Negative 2x plus 2x is 0. They cancel out. You're left with x squared minus 4. On the right-hand side, notice you have x squared minus 2 squared. Well, 4 is just the same as 2 squared. Now that's very important, that concept right there. And the reason it's important is that I want you to go back to letter A for a second. Notice a squared minus 25. It factors to a plus 5, a minus 5. X squared minus 2 squared, also known as x squared minus 4, factors to x plus 2, x minus 2. These are called difference of two perfect squares. A squared is a perfect square because that's just a times a. 25 is a perfect squared because it's just 5 times 5. And it's called a difference because you're subtracting in between. In order to factor a difference of two perfect squares that always factors to the following, you will take this value, so a squared, and split it up to a, and you're going to take the square root of 25 to 5 and 5, and your signs are always going to be minus plus. We can see it in the general form in example C. Instead of using numbers, we're using letters, A's and B's. Again, I can use my box method to prove it. A minus B, A plus B. A times A is A squared. A times negative B is negative AB. A times B is AB. And B times negative B is negative B squared. I can rewrite it. So A squared, like terms in the middle, minus AB plus AB, minus B squared. The AB's cancel, so you're just left with A squared minus B squared, which notice that's what the original said you had to show when you're done. Now I'm going to say it again. When you have a difference of two perfect squares, difference is subtract. And these are perfect squares because you can square A and square B. Or you take the square root of A, square it as A, the square root of B, square it as B. The way you factor it is by taking the square roots of A and B, add and subtract. Let's look at example D to go backwards as an example. This is x squared minus 9. Now, x squared minus 9 is a difference of two perfect squares. X squared is a perfect square. 9 is a perfect square. I can factor it to the following. X plus 3 times x minus 3. The square root of x squared is x. The square root of 9 is 3. Plus and minus in between. Equals 5 times x minus 3. Because due to lack of time, I'm not going to finish that. I just wanted you to see the difference of two squares there. For letter E, w squared minus 4. Also a difference of two squares. W squared is just w and w. The square root of 4 is 2 and 2, plus and minus in between. Again, I'm not going to finish solving it at this point. We will talk more about it tomorrow in class, but please work on these 6 problems that I left for you to try at this point, and I will see you in class tomorrow.